My name is Roshni, and today I am going to explain my major project credit risk modeling using machine learning. In this video, I will show you the complete process step by step, cell by cell, exactly how I build the model. So let's get started. Cell 1, importing libraries. In this first cell, I imported all the important Python libraries like pandas, numpy, and data handling, and matplotlib and cbond for visualization, and scikit-learn libraries for machine learning. These libraries are the foundation of my whole project. Then cell 2, loading the dataset. Here I loaded my dataset name loan detection CSV using data head, and I displayed the first 5 rows just to understand how the data looks and what type of columns it has. Third cell is check columns and data types. In the third cell, I check all the column names and their data types. This helps to know which columns are numerical and which ones are categorical. It's an important step before processing. Then cell 4, I used handle missing values. Then in this cell, I handle missing values. For categorical names, I fill missing values using the mode, which means the most common values. For numerical columns, I use the median. After this, my data sets had a zero missing entities. Cell 5, handle missing values and data drop, means the dropping any, remaining n, none. Just to be extra safe, I used to drop down to remove any leftover missing values. How the data set was completely clean and ready for the next steps. Then cell 6, data target column, last column, means encoding categorical data. In this cell, I used the label encoder to convert all categorical columns into numerical values. Machine learning models can't understand text. Then so I encoding this very important. I also identify the target column. Means this code is a loan status label. And then cell 7, split data into the features and the target, means the splitting features and target. Here I separated the dataset into the inputs and outputs. X contains all the independent features and Y contains the target variables, which is whether a loan is approved or not. Means dependent and independent. The independent means X and dependent means Y. Then test split. In this cell, I split the data into the training and a testing set. 70% data is for training and 30% for the testing. Um, this helps in the checking whether the model generalized well. Then cell 9, I'll create and train the model. Create and train the model means in this step I created a random forest classifier with 200 dates. Random forest is very powerful and gives high accuracy. I train the model using model that fit on the training data. Cell 10, predict on test set, means making prediction. In this cell, the model predict the loan status for the test data set. I printed the first 10 prediction to see how the model is working, and next step is the cell 11, and this evaluate the model. We are checking accuracy. This is one of the most important steps. Then the model achieve an accuracy of the 88.98%. Sorry, model accuracy 88.94%. This means the model is performing very well for the predicting loan approval. Then cell 12, predicting using a real sample from test set, means a confusion matrix plus sample prediction. Here I used a real sample from the test data set. The model predicted the loan status corrected. I also display the confusion matrix which show the true positive and true negatives, false positives and false negatives. Means next step is cell 13, and it is a classification report. Classification reports in this cell I printed precision, recall and F1 score. The model performance very well for that class 0 and moderately for class 1 because the dataset is imbalanced. Cell 14 visualization, the confusion matrix. Uh, Plot confusion matrix with a matplotlib. I using here libraries like a matplotlib. Uh, then in this cell I plotted the confusion matrix using a matplotlib. The visualization clearly shows how many predictions were corrected and incorrect. Here this is the graph confusion matrix matplot already plotted. Then classification report cell 15 and reprinting the report. This cell prints the classification report again just for clarity. This is for clarity. Classification report. Then cell 16 predict on a real row from data set. This real sample prediction. In this cell I used one real test sample and I compared the predicted and actual values. The result was corrected. Then cell 17 predict using a real sample from test set. Final decision output. This final cell uses an if-else condition. If the model predicts 1, it shows loan approved. If it predicts 0, it shows loan rejected. For the sample, the output was a loan rejected. Output is a loan rejected. Uh, all of this entire loan prediction means loan detection major project. Conclusion is so in this project I successfully built a credit risk prediction model using random forest. It gives an 88.94% accuracy and I can help banks in making quick and accurate loan decision. Feature enhancement. In this feature, I can approve this model by balancing the dataset using deep learning models, analyze the feature importance, and creating a web-based prediction interface. Outro, and thank you so much for watching this video.